Remember, logarithm is nothing more than exponent. There's a lot of problems in the two different reduced things that I gave you that had a lot of things about graphing. Basically, can you use y equals? I know it's tough, Michael, but I have faith in you. And I know you can do it. Reach for the stars, man. So a lot of the graphic stuff is, are you going to be able to identify where the asymptote is? And that's going to be very easy to do, even if you had to go to your tables to look at what's approaching. Yes, ma'am?
So can you type in the equation of a log?
Absolutely.
Graphic?
Yeah.
How do you do that though?
For which example do you want to look at? That one? I have a copy of that one. Let me pull that one up. So if I wanted to graph that, so it's log base 6 of x plus 6. You use the y equals, then you use the log base. Y equals, clear out. Log base is alpha window 5, I believe. And it's just log base 6. Oh. And there it is. And there's your graph. And then just, obviously I'm going to change my window, so. Okay.
How do you do this by hand?
Why?
I don't know. Well, like, what if it was like...
No, am I going to take away your calculator?
No.
Everybody gets a calculator except for Jared. Yeah, Bill.
I think you probably already said this, but for the determinant ones on the final, how are those worded? Because you can just type it in and say.
It's going to be, where is the determinant? I mean, when you have a determinant problem, it's going to be, if you have multiple choice, it'll probably be one of the guesses where you flip the sign, and then it'll come out. It still works, but it doesn't work right. It'd be something like that. It could be Kramer's rule, where what does it look like if you're solving for y? How would the setup look like? You take your answer column, put it into the y values. Yeah, it's going to be setup stuff, because you can press buttons all day long. So, Izzy.
So I don't know how much you are allowed to tell us during the final. Like, if I were to look at one piece and I forgot, what to click, row, window, all that stuff, and I came up and asked you if I needed to log or something, what you do?
I would probably say alpha window.
You would tell us.
That's because
You just hit the math button.
Or you just hit the math button.
Wait, but what if you're just putting regular log, then what would you do? Would you just do log base 1?
No, remember regular log is log base 10. So that's just the log button.
Oh, okay, I see.
So let's see, solving log equations. I want to look at that real quick on this one. So if you remember how to solve a log equation.
Which is that chapter
8 test, yeah, log base 4 of x equals 2. So how do you undo a log base 4? No, you for it.
Wait, what is this?
Wait, which one are you on right now?
He's on chapter 8.
The other pack.
Yeah.
Wait, which question?
In order to undo a log base 4, you have to remember the properties of logarithms. If you have a log base 4, you exponentiate it. So these are the same bases, gives you x equals 4 squared, so it's 16. Okay. Same idea with 17. Oh, sorry, that was number 16. Sorry about that. If I do 17, 10 to the 4x minus 1 equals 1,000. This is setting you up where you have to rewrite 10,000 as the same base as 10. 10 to the third. So what happens here is you get 10 to the 4x minus 1 equals 10 to the third. And then the exponents fall because you have the same base. Now what's also really nice is that if you forget this, you have a calculator. You have multiple guess questions. You can plug and chug. Okay? Yeah, Izzy. Oh, sorry.
I thought we were supposed to look at the other packet, so my questions are about the other packet.
Oh, that's fine. We'll go back and forth.
Or like,
Wait,
so
do you do after you get the 10 for?
17 through 20, it is like, I don't know if it's will you be able to just like go this form, you're able to.
Yeah, these are a little bit more complex. I'm gonna do a couple of these in a second. I'm just gonna start with the easy ones and go to the hard one.
But like, if there were to be like 4 answers or was the right answer, you could just like go with it.
Yeah.
Well, I mean, actually.
This one actually would be that bad, because go to your y equals and put this in your y equals and figure out what value is going to give you -1. You could, because then you just have to overwrite it. I mean, it's really fast to do. Okay. That's why I always say that when you're working with a multiple choice type test, if you forget how to solve, let's say you forgot how to solve that, but you have a calculator, you've got multiple choice stuff, you've got a y equals table. This is also a great thing for those of you guys to do in the ACT. If you forget how to do something, the table function on the calculator is your best friend, because I can type this in, 8 minus 9 alpha window 5 log base 7 of -7x minus 3. Oops. I go to my table. Oh, I gotta change the table set. What value is going to give you -1? Oh, so boo, that's not going to work. It's going to be a fraction, so you have to go find it. What is it?
Yeah, you're 10, 7.
So it just so happens that you get a fraction. Yes, sir.
Is there a way, like, when you have the table, that you want to search with value?
It'll let you search the dependent. It's not. Sorry. If you ask for dependent, I don't know if it's going to make it work. It'll allow you to put in a y value. Let's see what this does. Yeah. Come on. Yeah, it's not going to let you do that. You can only put in the x value, so you're not going to be able to search for a y. That's a bummer. So yeah, pretty easy for those. You will get some funky answers, but you get the idea that you can figure them out from there. Where's the other one on here I want to look at? Inverses. There are a couple of inverse problems. Remember, when you're dealing with an inverse, I'm going to look at this one first, then I'll go to the ones that are in the other packet. When you're dealing with an inverse, so the inverse.
Which package is the chapter 8 one again?
This is still, yeah. If I have to find the inverse of this function, anytime you find an inverse, okay, this is chapter 8, number 21. All you do is flip-flop the x and the y and resolve for y.
Oh, yeah.
So how do I undo a log base 7? You have to exponentiate it with a 7. So 7 to the x is y.
When you became a teacher, did you like forget this at first, and then you just had to like remember?
Yeah.
Remember all this stuff.
Yeah.
No, it's true, because embedded, like I said, my degree is I have a degree in math. Plain math, like, yeah, math. I have a math degree, but my other part of the teaching part is the emphasis in teaching. So I have a pure mathematics degree, bachelor's degree, but the emphasis of that degree then became teaching. So that's why I had more, that's why it usually takes longer for teachers to get degrees, because you got to get your major, and then you have to get your emphasis stuff. So, but you're right. I didn't do any of this stuff in college. Yeah. Yes, ma'am.
Did we do exponential growth this semester?
Yeah. Yep, this was all in chapter 8. This is all in chapter 8. Oh, no. You'll never have to do those. Emma had a good question on the same chapter 8 test stuff, number 22 and 28, where they're asking you to find what is the log base 2 of 100, given certain equivalencies. You'll never have to do that. Emma. These tests and these parts and these questions were written before we had log base buttons on our calculator. You'll never have to do it. Okay, so don't worry about it. Don't worry about it. Jared.
Was that your final answer?
Yes.
All right.
Let's get it.
Can you do 18? I don't know how the E stuff works.
Yeah. On 18 here, we have 2 e to the x minus 1 equals 9. So to solve for x, I'm working my way backwards, first of all. Add 1, divide by 2. So I get e to the x is 5. How do you undo e? Well, remember, undo e to get the x to drop is when you take the log base e of both sides. But log base e was natural log. So x is going to equal the natural log of 5. And natural, I see your eyes right.
No, I put it in decimal point.
That's all it is. When you take the natural log of, natural log stands for log base e. Okay? No, because I'm not going to take it up the right way. There's never a reason not to worry about it.
So you can just put that in?
Yeah.
Okay. So we're not going over any graphs?
I'll talk about when we get to the trig graphing, because that's a little,
Okay.
we can get into some a little bit more of the,
Well, yeah, I
that's
can
when
see
things
how
can get a
that-
little bit more
But with
intricate.
this, it's like,
Yeah, is he?
Can you do under other vectors?
Yeah, that's why I wanted to go back into here to show the inverse of those. Same idea with the other one, when you're doing inverses here. First thing you do is flip-flop x and y. So x is going to equal 3 to the y plus 2. Subtract 2, I get x minus 2 equals 3 to the y. Now to get the y to drop out of the exponent, I have to take the log base 3 of both sides. So you get the log base, 3 of the quantity x minus 2 equals y.
Is that your final answer?
Yeah. That's it and that's all. Oh, do you want to use my phone? All right, no, that's fine. And then on the other one, you have y equals e to the x plus 10. You flip-flop them, you're going to get x minus 10 equals e to the y. I just did that in one quick step. And then how do I drop the y? Bada bing. Bada boom.
So when you do the natural log, you're multiplying it by.
Yeah, natural log is log base e. Yeah, this one. This packet. Condense. So this first one means log base 3 of x to the 4th. Okay? The second one means log base, base 3 of y to the 16th. The subtraction symbol between the two means what? It's division. So you wind up with log base 3 of x to the 4th over y to the 16th.
Wait, why does it mean division?
That was the rule when we were condensing and expanding.
wait, but that says y. Oh, so it's still.
It's okay. It's okay. Because you have the same log base when you have subtraction between the two. Means when you condense it, it's division.
so number 9 is expanding.
Correct. Number 9 is going out the other way. So you get,
Multiplication is just like adding.
correct. You'll have 3 log base 5s.
Yeah.
So you wind up with log base 5 of 3 plus log base 5 of 10. And then since it's going to be 7 squared, I'll get 2 log base 5 of 7. I can do that in one fell swoop. Yes, ma'am.
This isn't really just that question, but when you're graphing logs, the range is always all reals, right?
Yeah, hold on. My,
Any what?
This weekend.
Study for this?
I'm no math major.
Why are we going to graduation?
I'm sorry, I've never listened to you. I was talking to Mr. Smith. What's up?
So for when you're graphing logs, range is always all real.
Yes, because you can have, your range will be all real because your domain will have the vertical.
I'm still gonna go anyway.
But when you have exponential growth and exponential
Oh, so
decay,
she
you
didn't
can still
have
do
it
it.
because you saw it.
Bonjour!
Yeah.
Izzy!
Can you give your six?
I'm gonna start charging you. On this one? In order to solve these equations, either one of them, it's forcing you to set them up to have the same base. So in 16, it's straight and get you to get a base 2. 16 is 2 to the 4th times 3x is 2 to the 6th times 2x. Do they have the same bases?
Yeah.
What happened to the exponents? Does 12x equal 12x?
You could say that.
Yeah, but it just says solve, that's why.
Right. So what's your answer?
0.
All real numbers.
What the?
It's all real because it becomes what's called a true, bless you. It becomes a true statement. When you get a true statement, 12x equals 12x, or x equals x, or 1 equals 1, or whatever, you get all real numbers.
Did you do the one before that? I think we did it previously, but.
Yeah, what happens with this is a little bit trickier. Now, what'll happen here is that you get, it's trying to get you to write everything in base 5. So 625 is 5 to the 4th. 1 over 5 to the 4th is the same thing as writing it as 5 to the negative 4th. You okay with that? Since I'm dividing by 5 to the 3a, if I bring that up, it becomes times 5 to the negative 3a, which equals 5 to the negative 2a plus 2. Now, on the left-hand side now, do you have the same base?
Yeah.
With different exponents, and I'm multiplying, which means I add my two exponents together. So that's the exact same thing as saying 5 to the negative 3a minus 4 equals 5 to the negative 2a plus 2, and now the exponents drop. Equals negative 6, right? And the other thing that's nice about this, Ben, is that you could look at that problem and go, oh, whatever we're going to do. But you could always plug and chug. It takes a minute longer, so if you're stuck on, it's one of those problems that you can start playing around with if you get a little bit of time, because you can put that in your calculator and just try to substitute out, see what you get, and try it out. So, yay! I'm the same. So we have multiplication between the two, and there's also exponents between the two. So when I have an exponent and a multiply, I know there's going to be two different logarithms. So it's going to be log base 4. Oops. It's z to the 4th, but I'm going to put the 4 out front. So it's 4 log z4. Z0, whatever. Plus. Cube root is the same as what exponent?
1/3.
1/3. It'll be plus 1/3. Yeah, Jerry.
When do you know to put it out front or put it up by the z or the x?
If I'm expanding, it goes out front. If I'm condensing, it goes to the exponent. That's what that looks like.
Can we do 12?
Yeah.
Would that just be like log 2 times 1/2?
I said another log. So we can condense this out. All right, so we have log base 2 of 11 cubed times Yeah, that would be 1/2 because it's out here, so that should be up front here. Yeah, so then, that'd be 5 to the 1/2. Thank you. I was looking at it going, wait, why are they writing that like that? That's why there's no other one there. What happened here is that this really is 1/2 log base 2 of 5. So they might not have written it as to the 1/2 power. They might have written it as the square root of 5. Did their solution write it as the square root of 5 or the 1/2 power? Square root of 5? That's what that looks like. Yeah, there's an answer key. Oh, that's right.
Oh, wait, yeah, that's right, that ruler is like with the coefficient instead of the exponent, right?
Which one? Which number? How much is it? Solve the equation. Okay, what this one is forcing you to do is to condense the left-hand side so you get the same log base. When you get the same log base, you exponentiate both sides and the logs go away. So here you wind up with log base 5 of, let's see, x squared over 2.
But then you can put the 5 in the drop.
Right, and that's going to equal the log base 5 of 2x plus 6.
Can you get the over 2 in the first part?
It says it's minus log base 5 of 2. Since I'm subtracting, it means I'm dividing it by 2. So if you exponentiate both sides with 5, you're going to get x squared over 2 is 2x plus 6. So then you get a quadratic. So you're going to get x squared minus 4x minus 12 is 0. X minus 6, x plus 2. I have possible zeros at 6 and negative 2. And then you just have to check them to see which one works. One of those is probably extraneous. Yes, ma'am?
Okay, so if this were actually a test of principles of choice, and you got to after the log part, and you have just the numbers of the x and stuff and stuff, or the code stuff, I guess, like there, can you just fill in the answers there? Is there any word if you have the
You know what? If this was a multiple choice test and I had no flipping clue what I was going to do, I'd go right here and just substitute in and just go. Because it's not that long to do it. Plus your calculator will allow you to overwrite. I mean, seriously, there's,
You said just sub it.
you know, or do this. I know that I could, since they're all the same log base, just test taking wise, I can write it as 2 log base 5 of x minus log base 5 of 2x plus 6. Will that equal log base 5 of 2? Because I can quickly look at that decimal in my calculator. See what I did just using like a literal equation, just moving stuff around. Because now all I have to do is substitute in my possible scenarios once and just hit enter a bunch of times and just change those out just by overwriting my entry. Ladies and gentlemen, you have a calculator. It's the greatest invention known to man. I know you don't like them because okay. Let's see, what else was there with logs? Log, it's big, it's heavy, it's wood.
Wait,
It's log, it's better than bad, it's good.
how do we do log if there's only like one on one side?
Oh, to solve equation one? That's right, I didn't finish one of those out. So if you had to solve an equation here, I got number 18. First thing I have to do is move everything that doesn't have the log part to it. So I'm going to subtract 1 and divide by negative 3. So I get log base 12 of 7x plus 5 is negative 2.
Oh, and then would you just
and then work from there. It's a lot easier than it looks.
I like that.
Well, what does negative three go?
Yeah, with the negative, yeah.
We divided it out.
7 minus 1 is 6. 6 divided by negative 3 is negative 2.
Oh.
Yeah. I didn't see the plus one.
And this is another one that you said you could just put it in the database.
Yeah, you could try and do that. But I think this one gives you a crummy decimal, so you're not going to be able to find it. Your table value isn't going to give you crummy decimals. If you put that in there, you could change your independent values to those, and it'll automatically substitute it for you. It's just as fast to do it in the regular calculator part. Math. No, it'll be 7x plus 5 equals 12 to the negative 2.
Oh.
So it'll be 7x plus 5 equals 1 over 144. And then you subtract 5 divided by 7.
That's really gross.
It is really gross.
I don't
Like
want
your
to.
face. Sorry, Jared.
That was good. That was enough gross.
You guys are missing. You guys are gonna throw stuff at me as you walk by me next year. Probably. Then you'll just be crying. Logs, yeah, anyways, that's fun. Izzy, before I go on to trig,
You might just split this up.
I just thought I'd ask. Miss Emma.
Okay, it's on the first page, like, I forgot how to simplify when it was, no, for number 9 was like log 1 over 100. It's like,
Oh, log base 10 of 100?
Oh, so you gotta do this log.
It's asking you to evaluate that. What is the standard log base that you never see? 10. So this is basically the same idea as log base 10 of 10 to the negative 2. So your answer is negative 2. Or you can just put it in your calculator and get your answer. Because when you hit if there's no base shown, it's automatically assumed to be a log base 10.
and I was doing the right one. Like, I would check it. I got
Well, that would be, so you have 2e, it's 2e times 4e times, so this one, when you rewrite out, you wind up with negative 8e squared over e cubed. So it's negative 8 over e. You use your exponent rules like you would whether it was an e, an x, a y, 6, 12, 32, 18,
24.
pi.
72.
What's that? Trig, yay!
This wasn't that bad.
I love trig.
Well, except for
It's my
once you get
favorite
into
thing.
solving.
I love
that.
Liar.
The 1 plus n equals this.
Trig. I know. The first bit of trig that you guys started working with was pretty straightforward. Good old-fashioned SOHCAHTOA. We had the SOHCAHTOA stuff. We had radians versus degrees. Yeah, Mike.
I noticed when I was doing this last night, I didn't have my calculator in degree mode, so it messes a lot of.
Oh, when you're trying to find your values yeah, you gotta be careful with that. Whenever you're solving for angles within triangles, it's always gonna be in degrees. You guys all remember how to change your mode in your calculator, right?
Yeah.
Oh,
Okay.
Mode.
So there's a button on your calculator that says mode.
You go from radian to degree.
And you change it from radian to degree.
Wow.
Okay? So if you're trying to if you're solving anything that has triangles, okay? Anytime you're working with triangles, you're always going to be in degree mode. If you're not in a triangle, you're always going to be in radians. Then again, remember a lot of times when you're solving stuff that were in radians, I didn't let you have the calculator anyway. Remember that whole time frame?
Oh, yeah.
Where you guys basically didn't use a calculator for like 2 months, 3 months straight?
Yeah.
Then all of a sudden you guys got a calculator, you're like,
to class for some
what is this?
That's when we started asking for everything. Wait, do we get a calculator?
I know. So remember that next year, because you'll do really well if you don't rely upon your calculator a lot. You really will. I try to set you guys up big time for all the trig that they do in pre-calc. And if you guys did fairly decent at figuring out trig after a while without your calculator. You know, your co-terminal angles, what quadrants do you wind up being in, and being able to do that in pre-calc is just going to really benefit you. So in, let's see, the thing something.
Wait, the things look like you're.
Let's see. So the chapter 13 little test stuff on here. What I want to do real quick is just kind of remind you guys on like number 17 or excuse me, number 20.
What is water science?
How do you solve the rest of the triangle?
You do sine of.
Oh, it's 80 over 20 equals 60 over whatever.
Yeah, this is a law of sines problem. Okay. When you're given the two angles, you find your third, you wind up using the law of sines. Law of sines was that ratio. The sine of 80 is to the side opposite, as the sine of 60 is to its side opposite, as the sine of 40 is to its side opposite. Okay.
That's odd.
This one works out nice because it's an angle side angle scenario. You don't have to worry about the ambiguous case.
Are we gonna talk about the ambiguous?
That's the one where we made the second triangle. It's possible.
I did not know how to do it.
So like in 20,
I think I figured it out.
I think 21. So you have angle, so you have a triangle ABC, and angle C is 40 degrees. Little a is 10, and little b is 20. Is this setting you up to have to check for an ambiguous case?
Probably.
Yeah. Okay.
You just make
The
it up.
ambiguous case is the one where you can have more than one triangle.
How would that
Oh, I
look on the
hated that
test?
so
Would
much.
it be like, is there
Is
more
that
than
gonna
one
be
triangle?
really-
It's possible, but take a look at what happens though. Which angle would you try to find first?
B or?
B.
Yeah.
I go for B because it's going to be a larger angle. Okay. So I know that I have to first of all use the law of cosines now.
Which one is that? Wait, I forgot that one.
Oh, wait.
Oh, it's like
Any
A
of this.
squared.
So it's going to get you. We're going to find little. Actually, we have to find little c first.
Wait, which one is the one?
So law of cosines was little c squared is a squared plus b squared minus 2ab cosine c.
Wait, hold on, I gotta write this down.
Jump equals 9.10.
I just hope I get really lucky on the title. Yeah. Hey, just go with B today.
We can plug that
It
in
can go B.
and not have to do this.
No, it doesn't work with triangles. So now you have, what is this, 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of 40. So if I put that in my calculator, thanks. It's not bad because you can just put it in. 10 squared plus 20 squared minus 2 times 10 times 20 cosine 40.
193.
So now I gotta take the square roots of my answer, and I get 13.91. So little c is 13.91.
Really?
Yeah.
Yeah. Now to figure
Oh,
out,
you use a lot.
now I use law of sines. Because now I'm gonna use law of sines because I have a pivot. So the law of sines says that the sine of 40 is to 13.91 as the sine of angle B is to 20. This is a cross multiply problem.
Wait,
So you get 20 sine 40 over 13.91 is the sine of B. That's a rock. That's what this love is.
Your point is right.
That's 0.92420935.
So I have some crummy decimal equals the sine of B, so I hit inverse sine of my answer, and angle B is coming out at 67.55. Now the trick.
The supplement.
Check to see if the supplement's going to allow you to create a triangle. Okay? So if angle B is 67.55, what's the supplement to it? What is it?
180 minus that, right?
I'm going to call that B prime. 112.45. Now, here's what we do. I know that the 67 plus 40 gives me enough angle measure left over for angle A. Does 112 plus 40 give me enough angles for angle A?
Yeah.
This is a two triangle setup.
So are like the sides the same on 20?
The 20 to 10, the sides are going to be the same, but you wind up with you could get two different angles to make this work.
So wait, is then C on the second triangle still 40?
Yeah.
Okay.
So you have the possibility that the secondary triangle could exist. So you have angle C could still be 40. Angle C is still 40, which means that angle A in this case could be something, and angle A could be something else here, which gives you two different side lengths for A.
So then you just add the.
You just add these two together, subtract from 180, so you're going to get 130, 152, so it'll be 27.55.
Yep.
And then the other one would be 107, so it'd be 73? No, 72.45? I didn't see that. Think about the amount of time it takes to do a double triangle.
Yeah.
Yeah, come on. Yes, ma'am.
I know it's like the easiest part of this, but can you go over like 30 and 1 and the second packet? That something really kind of hard.
Sure.
One second.
Not the word music.
Find a positive and a negative coterminal. What's up? For $1.
I didn't win the mega, I'm broke.
All right. Somebody in Blue Island won it, I guess.
I know.
So you got positive and negative coterminal angles here. So when we start with the negative, we have negative 13 pi over 4. That just means that we're going the opposite direction to start. We're going to go clockwise. Start clockwise 4 and spin around. 13 pi over 4. 4 goes into 13 how many times?
3.
So it's negative 3 and a fourth pi. So as we count, here's 1 little, 2 little, 3 little pi's, quarter. So I'm in the second quadrant. Yeah, so if I want, now did I go more than one revolution negative?
Yeah.
I did, so I need to back it. When you're doing positive, negative coterminal angles, you're always going to be plus or minus 2 pi. So if you think about it, if I go negative from here to here, that's, well, that'd be, bless you, be negative, what is it, 5 pi over 4. So the negative, this is 4 pi over 4 plus a quarter pi, so it'd be negative 5 pi over 4. And then the positive, it's like, oh. The positive, that's 3 pi over 4, right?
Yes. I thought, like, didn't you say this one time that, like, the positive shit, like, the next one that 4 goes into would be 16, so then it would be plus 3 pi over 4, so that's the thing.
So That's, I mean, it's easier to get the reference and you just look at where it's going. Okay. Ben first, and I'll come around.
The thing you do, what's the thing you do with cosine of this, where it's like you can't do it, it's on a certain quadrant. and it's like-
That's when you're finding the angles. We'll probably get to that stuff tomorrow, 'cause that's more for chapter 14 stuff. Because cosine was positive, these two,
And then-
sine was positive, these two.
Oh, no.
What were the equations?
Oh, that is something, I'll have to look it up. I don't know which one of you two were first.
Probably me.
Ladies first.
Can you just do the string where you add 8
Yeah, you can do that too. Yes, sir.
Which one do you write, which one's your answer?
Okay, it said one, I think it said one of each, a positive and a negative
Oh,
quotient. I think
yeah.
that's all it was.
Okay, so easy 32, but. Is that
You get it.
35, negative 35 pi over 12. Well, that one stinks. Negative 35 pi over 12 is just a shade under 36 pi over 12, so it's just a little bit less than 3 pi. Okay? So if we're spinning around, 1 little, 2 little, almost 3 pi's. So I've got a reference angle bounced off of that negative, pi over 12. I don't think we ever we didn't deal with pi over 12s, but it's not difficult to add it in. Okay? So if I want to look at a positive one, that one's pretty easy. It's pi plus a 12. So it'd be 13 pi over 12. Okay with that? Because pi is 1 over 1, it'd be 12 over 12, and I just add a 12, so it'd be 13 pi over 12. There's my positive one. If I go the other direction, think of it the other way. This is negative 13 pi, or excuse me, it's negative 12 pi over 12, so it'd be negative 11 pi over 12. Very good.
We never had to deal with like the angle measure of this part, right?
No. No, you won't have to find, you guys will not have to solve for anything that would not occur on your unit circle until next year. Then you'll deal with half angles and double angles.
Oh, that's the.
Well,
It's actually a pretty simple formula. Once you guys know how to find, you guys know your ordered pairs. Well, you probably don't remember them right now, but once you see them again, you go, oh yeah. And as long as you remember your 30, 60, 90, how everything is bounced out of those, then it's gonna be all right. Yes, ma'am.
When did you say we're doing that honest feedback homework?
I don't know. I should ask Cindy about that. We didn't